Good morning everyone. Today we are going to learn the concept relationship between zeros and coefficients of a polynomial in the chapter polynomials of 10th class. So mainly in this concept we can discuss about the linear polynomial, quadratic polynomial and a cubic polynomial. First let us go for a linear polynomial. Linear polynomial. So already we know linear polynomial has how many number of zeros? Linear polynomial has only one zero. So we know the general form of a linear polynomial is p of x is equal to ax plus b comma a not equal to 0, a comma b belongs to real numbers. It is the general form of a linear polynomial. So we know it has only one zero. Let the 0 be alpha. It is a Greek vector. Let alpha be the 0 of this polynomial, then p of alpha is equal to 0. P of alpha is equal to 0. That means you can substitute in place of x as alpha. This implies a alpha plus b is equal to 0. A alpha is equal to minus b. Alpha is equal to minus b by a. So alpha is the 0. B and a are nothing but what? Coefficients of this polynomial. So alpha is equal to minus b by a. This can be written as minus b. Means what? In this polynomial b is constant, a is coefficient of x. So minus constant term it's divided by coefficient of x. So the relationship between zeros and coefficient of a linear polynomial is minus b by a, that is nothing but minus constant term by coefficient of x. If they ask anyone problem, find the relationship between 0 and coefficients of the linear polynomial p of x is equal to some 3x minus 2. Then simply we can write x is equal to, let alpha be the 0. Alpha is equal to 0 of this polynomial is nothing but 2 by 3. This can be written as minus of minus 2 by 3. Minus of minus 2 by 3. Why I am writing here minus of minus 2 by 3 means the relation is minus b by a. So minus b is nothing but what here. If we compare this expression or this polynomial with ax plus b, then we get a is equal to 3, b is equal to minus 2. So minus into minus plus 2 here. So minus 2 is nothing but what? B. It's divided by 3 is nothing but a. So finally alpha is equal to minus b by a. The 0 of the polynomial, 0 of the linear polynomial is nothing but minus b by a, with b is a constant and a is a coefficient of x. This is about relationship between zeros and coefficient of a linear polynomial. Next, go for a quadratic polynomial. Quadratic polynomial. So already we know quadratic polynomial has how many number of zeros? Quadratic polynomial has at most 0, at most 2 zeros. Quadratic polynomial has at most 2 zeros. Quadratic polynomial has at most 2 zeros. Let us consider the 2 zeros are alpha and beta. Alpha and beta are the 2 zeros of the quadratic polynomial. Already we know if alpha is the 0 of the polynomial, let us consider the polynomial as p of x. If alpha is the 0 of the polynomial p of x, then which is the factor? X minus alpha is a factor of p of x. Already we discussed in a previous video. Alpha is the 0 of the polynomial p of x, then x minus alpha is a factor of p of x. If beta is the 0 of the polynomial p of x, then x minus beta is the factor of p of x. So see here, let us consider the quadratic polynomial. The general form of quadratic polynomial is ax square plus bx plus c comma a not equal to 0, a b c, a comma b and c belongs to real numbers, where a is x square coefficient, b is x coefficient, c is constant. Okay, already we discussed alpha and beta are the zeros of this polynomial. Then x minus alpha and x minus beta are what for this polynomial? Alpha and beta are the zeros of this polynomial. Then x minus alpha and x minus beta are the factors of p of x. Factors of p of x. So that we can write from these two expressions, we can write x minus alpha into x minus beta. That means, for suppose we consider 6. 6 is the number. 2 is the factor of 6 and 3 is the factor of 6. We can write 2 into 3. That product is equal to 6. 2 into 3 equal to 6. So if we can split 6 as 2 into 3. 2 into 3 is equal to 6. We can split this ax square plus bx plus c also into x minus alpha and x minus beta. That are the factors. So that x minus alpha and x minus beta can be written as ax square plus bx plus c. See here, if we multiply x and x, we can get x square. X and x is nothing but x square. Here x square coefficient is a. If we multiply x and x, we get x square. That coefficient is 1. 1 into x square, we will get 1 into x square. But here a into x square. A is not always 1. X square coefficient is not always 1. So that we can give any real number in this place of a. So that I want to consider k is any real number. Then k into x minus alpha into x minus beta is equal to ax square plus bx plus c, where k not equal to 0 and k belongs to any real number. If k equal to 0 means that it is not a quadratic polynomial. So that k not equal to 0 and k belongs to any real number. So this is the equation. Now I have to split, expand this equation. Multiply this x into x square minus alpha into x is nothing but alpha x. X into minus beta x minus alpha into minus beta, nothing but alpha beta. See here 2 terms, here 2 terms, 2 into 2, 4 terms, 1, 2, 3, 4 terms we can get. So x square minus alpha x minus beta x plus alpha beta is equal to ax square plus bx plus c. Okay. Next, k into x square minus, if we observe in these two terms, what is the common value? In these two terms, the common value is minus x. Here minus x we have and here also minus x we have. So common that minus x, here minus and x, common that. Then remaining is here alpha and here beta, alpha plus beta. So if we multiply minus alpha into x, minus alpha x, minus into plus minus beta x plus alpha beta is equal to ax square plus bx plus c. Next, now multiply with k into x square. K into minus alpha plus beta into x minus k into alpha plus beta into x plus k into alpha beta, k alpha beta is equal to ax square plus bx plus c. Ax square plus bx plus c. Now compare on both sides. Here x square coefficient is a, here x square coefficient is k, here x coefficient is b, here x coefficient is minus of k into alpha plus beta. Here constant term is c, here constant term is k into alpha beta. So that we can compare it on both sides. Then we get, comparing on both sides, then we get a is equal to k and b is equal to minus of k into k is equal to a, and minus k into alpha plus beta is equal to b, and k alpha beta is equal to c. K alpha beta is equal to c. The k value is a here. So alpha plus beta is equal to, here minus k is multiplying with alpha plus beta, then it goes to this right hand side, then it becomes division b by minus k. Here alpha beta is equal to c by k. So this b by minus, right, as is the value of k is here a, b by minus a. Here alpha beta is equal to c by k value is a. So finally alpha plus beta is equal to b by minus a in standard form is nothing but minus b by a, and alpha beta is equal to c by a. Alpha beta equal to c by a. So this is equal to See, B is what here? B is coefficient of x. A is coefficient of x square. C is constant term. So minus B is nothing but coefficient of x. Coefficient of x. It's divided by A is nothing but coefficient of x square. Coefficient of x square. Similarly, C is nothing but a constant term. Constant term. By A is nothing but coefficient of x square. Coefficient of x square. So finally, what we have to conclude? Alpha plus beta. Alpha and beta are the zeros of this polynomial p of x. So that alpha plus beta is nothing but sum of the zeros. Sum of the zeros is equal to minus coefficient of x by coefficient of x square. And alpha into beta is nothing but product of the zeros. Product of the zeros is equal to constant term by coefficient of x square. Finally, if alpha and beta are the zeros of the polynomial, then the relationship between zeros and coefficients of a quadratic polynomial is this one. Okay. Next, here one more important point is, they will ask a question like this: if alpha and beta are the zeros of the polynomial, then find the quadratic polynomial. Otherwise, find the quadratic polynomial whose zeros are alpha and beta. Find the quadratic polynomial whose zeros are alpha and beta. So at that time we can find by using this formula, k into x square minus this one, k into x square minus alpha plus beta into x plus alpha beta, where k not equal to 0, k belongs to R. If alpha and beta are the zeros of the polynomial, then the quadratic polynomial is k into x square minus alpha plus beta into x plus alpha beta. If they ask a problem like this, find the quadratic polynomial whose zeros are 2 and 3. Find the quadratic polynomial whose zeros are 2 and 3. So let us consider alpha is equal to 2 and beta is equal to 3. Alpha is equal to 2, beta is equal to 3. Therefore, the quadratic polynomial whose zeros are alpha and beta is k into x square minus alpha plus beta into x plus alpha beta. So that find first alpha plus beta. 2 plus 3 is equal to 5. Alpha beta 2 into 3 is equal to 6. So finally, k into, substitute in the polynomial, p of x is equal to k into x square minus alpha plus beta value is 5 into x plus alpha beta value is 6. So for k is equal to, we can give here any real number, then we get the zeros are 2 and 3 only. So I am giving x square coefficient k is equal to 1. Then the quadratic polynomial is x square minus 5x plus 6. For suppose, if we consider the zeros are 2 by 3 and 4 by 3. If we consider the zeros are 2 by 3 and 4 by 3, then find the quadratic polynomial. If they ask like that, at that time you can find alpha plus beta is equal to 2 by 3 plus 4 by 3 is nothing but 6 by 3 is nothing but 2. Alpha beta is equal to 2 by 3 into 4 by 3 is equal to 8 by 3. Now substitute these values in this polynomial. P of x is equal to k into x square minus alpha plus beta value is 2, x plus alpha beta is 8 by 3. Okay. So now take the LCM. LCM is 3 here. So we can get 3x square minus 6x plus 8. So in this particular we get the denominator. In denominator the value is 3. In this particular time we can write the required polynomial is for k is equal to what we get in the denominator, that value is nothing but k equal to 3. For k is equal to 3, the quadratic polynomial is 3x. So we get in denominator like 3, 5, 7, anyone. At that time we can write for k is equal to 3. Then the quadratic polynomial is like this. What we have in the numerator, that is nothing but our required polynomial. You can give any value, k is nothing but real number. You can give any real number, but in particular, if we get in denominator as like this, at that time we can write k value as the denominator. Then we get the required quadratic polynomial. So that finally, if the quadratic polynomial whose zeros are alpha and beta is k into x square minus alpha plus beta into x plus alpha beta, where k not equal to 0, k belongs to R. So this is one of the model. In another way, they will give problem like this. Find the quadratic polynomial whose sum of the zeros is 3 and product of the zeros is 4. Whose sum of the zeros is 3 and product of the zeros is 4. Here directly they have given sum of the zeros. Let us consider the zeros are alpha and beta. Sum of the zeros they have given, that means alpha plus beta is equal to 3. And product of the zeros they have given alpha beta is equal to 4. Then directly substitute these values in this quadratic polynomial. Then we get the required quadratic polynomial. Nothing but k into p of x is equal to k into x square minus alpha plus beta into x plus alpha beta. So k into x square minus 3x plus alpha beta is 4x. Alpha beta is 4. So for k is equal to here, what we have to write? For k is equal to here, there is no denominator, nothing but 1. So k is equal to 1. The quadratic polynomial is x square minus 3x plus 4. We have to remember they have given zeros or sum of the zeros and product of the zeros. That we have to remember clearly. So if the sum of the zeros they given means alpha and beta values they particularly given. If sum of the zeros and product of the zeros they have given means they given alpha plus beta and alpha beta. That you have to write first. Then after substitute those values in the given on the formula, then we can calculate, then we can get required polynomials. So this is about if alpha and beta are the zeros and sum of the zeros and product of the zeros they are given means how can we find the quadratic polynomial? That is about that. Next, if they asked find the zeros of the quadratic polynomial and verify the relationship between zeros and quotients of the polynomial. Find the zeros of the quadratic polynomial and verify the relationship between zeros and quotients of the polynomial. And if they ask a problem like that, how can we calculate? Let us see. So let us consider the question is find the zeros of the quadratic polynomial x square plus 7x plus 10. Find the zeros of this polynomial x square plus 7x plus 10 and verify the relationship between zeros and quotients of this polynomial. Like that they ask me, how can we do? See, first let p of x equal to x square plus 7x plus 10. Let us assume that the polynomial p of x equal to x square plus 7x plus 10. First of all, we have to calculate the zeros of this polynomial. So to find zeros, let p of x is equal to 0. P of x equal to 0. P of x is nothing but x square plus 7x plus 10 is equal to 0. How can we calculate the zeros of this polynomial? So how to multiply x square quotient and constant term. X square quotient is 1 here and 10 constant term. 1 into 10 is nothing but 10. Now we have to split 10 into 2 factors. The 2 factors sum must be 7. So there are 10. 10 can be written as 2 into 5. Now 2 into 5 is nothing but 10. 2 plus 5 is nothing but 7. So x square plus 7x can be split as 2x plus 5x plus 10 is equal to 0. So in these two terms, what is the common value? In these two terms, the common value is x. Then remaining is x plus 2 plus. So how to write x plus 2 directly here? So by what number we multiply x, then we get 5x. By multiplying x by 5, then we get 5x. So right here 5. 5 into x, 5x, 5 into 2, 10. In these two terms, what is the common value? X plus 2. In these two terms, the common value is x plus 2. And here remaining is x and plus 5 is equal to 0. Therefore, finally, x plus 2 is equal to 0 or x plus 5 is equal to 0. The product of two terms is equal to 0. Then either of the terms is equal to 0 or both is equal to 0. X plus 2 equal to 0 or x plus 5 equal to 0. Therefore, x is equal to minus 2 or x is equal to minus 5. Minus 2 and minus 5 are the zeros of this polynomial. Now, we can verify the relationship between zeros and quotient of a polynomial. Relationship. relationship between zeros and coefficients. Coefficients of a polynomial, of a quadratic polynomial. See, first how to compare this polynomial, given polynomial with the ax square plus bx plus c. Compare the given polynomial with ax square plus bx plus c. Then we get a is equal to 1, b is equal to 7 and c is equal to 10. Now, what are the zeros we got? Minus 2 and 5. So, we have to minus 2 and minus 5. You have to assume that two zeros with alpha and beta. Let alpha is equal to minus 2 and beta is equal to minus 5. Are the zeros of the given quadratic polynomial x square plus 7x plus 10. Now, what is the relationship between zeros and coefficients of a quadratic polynomial? Alpha plus beta is equal to minus b by a, alpha beta is equal to c by a. That we have to verify. So now, alpha plus beta. Alpha plus beta. What is alpha? Minus 2. What is beta? Minus 5. So minus 2 minus 5 how much? Minus 7. This minus 7 I want to write as minus 7 by 1. Minus 7 by 1 is nothing but minus 7. That is equal to minus right as is. What is 7? 7 is nothing but b. 7 is nothing but b. It's divided by 1 is nothing but a minus b by a. So verify. Alpha plus beta is equal to minus b by a. Alpha plus beta equal to minus b. For suppose if we not written this one. But we know already alpha plus beta is equal to what? Minus b by a. So how to calculate up to here and then write, leave some space and then write is equal to minus b by a. Then from this we can write the actual expression here. So minus, keep as is, what is b? 7 by what is a? 1. Minus 7 by 1 is nothing but minus 7. So write directly, otherwise like that also no problem. Alpha plus beta is equal to minus b by a. Now alpha beta is equal to minus 2 into minus 5. Minus 2 into minus 5. Minus 5 is equal to 10. So then we can write as 10 divided by 1 equal to c by a. 10 is nothing but what? C. 1 is nothing but a. Otherwise we can write c by a. C is nothing but 10. It's divided by a is nothing but 1. So finally alpha beta is equal to c by a. So alpha plus beta is nothing but sum of the zeros is equal to minus b by a. Means b is constant or minus quotient of x divided by quotient of x square. Product of the zeros is equal to constant term by quotient of x square. Okay. This is about the relationship between zeros and coefficients of a quadratic polynomial. Now we are going to discuss the relationship between zeros and coefficients of a cubic polynomial. So already we know cubic polynomial has how many number of zeros? Cubic polynomial has at most 3 zeros. So let us consider that 3 zeros are alpha, beta and gamma. Cubic polynomial. P of x is equal to general form of cubic polynomial is ax cube plus bx square plus cx plus d. This is a not equal to 0, a, b, c, the blank beta and gamma are the zeros of the cubic polynomial and gamma are the zeros of this cubic polynomial. So alpha, beta and gamma are the zeros of this cubic polynomial. Means which are the factors? X minus alpha, x minus beta and x minus gamma are the factors of p of x. So from these two we can write as x minus alpha into x minus beta into x minus gamma is equal to ax cube plus bx square plus cx plus d. Here same as a quadratic polynomial. Here x cube quotient is a, x into x square into x cube quotient is 1. But a is not always 1, so that we have to consider one real number, that is k, and k is not equal to 0. K belongs to real numbers. So k into x minus alpha into x minus beta into x minus gamma is equal to x cube plus bx square plus cx plus d. Now multiply these terms. So k into, if we multiply these two terms, what we get? X square minus alpha plus beta into x plus alpha beta, already we have seen, and x minus gamma is equal to ax cube plus bx square plus cx plus d. So now multiply these two terms with this one, this term with this one, k into x square into x cube minus alpha plus beta into x minus alpha plus beta into x square, alpha beta into x, alpha beta into x, alpha beta x, again x square into minus gamma x square, minus into minus plus alpha plus beta into x into gamma x, and plus into minus alpha beta gamma. So now multiply these terms by these terms, then we get here 1, 2, 3, here 1, 2, 3 into 2, 6 terms, 1, 2, 3, 4, 5, 6 terms we got. So is equal to, what we get, ax cube plus bx square plus cx plus d. Okay. Next, this implies k into x cube. So here x square term is there, here also x square term is there, minus. So minus x square, how to common in this term and this term. So minus of alpha plus beta plus gamma into x square will get. Next here, if you here x term is there, here also x term is there. Now multiply with this one, what we get? Alpha into gamma plus beta into gamma. Here alpha beta into x. So totally from this term and this term we can common x, then what we get? Alpha beta plus, here already x common, multiply with the alpha and gamma, alpha gamma plus beta gamma. I want to write in order, beta gamma plus gamma alpha. From these two terms common x, then we get alpha beta plus beta gamma plus gamma alpha into x, and remain here minus alpha beta gamma is equal to ax cube plus bx square plus cx plus d. Okay. Next, now multiply with the k into x cube and k into, now multiply with these total expression with k, then we get some value and equal to x cube plus bx square plus cx plus d. And finally we can compare on both sides, then we get a is equal to k, whereas k is equal to a, and k into this one minus k into alpha plus beta into gamma into x square. Here x square coefficient is b, so minus k into alpha plus beta plus gamma is equal to b, and k into this one, k into x coefficient, k into alpha beta, k into alpha beta plus beta gamma plus gamma alpha is equal to, here what? X square coefficient, x coefficient c. Next, finally k into minus alpha beta gamma, nothing but minus k into alpha beta gamma is equal to here d. Okay. From this we can write this as 1, 2 and 3. So from 1 we can write alpha plus beta plus gamma is equal to b by minus k. So this can be written minus b by k is nothing but a. So finally alpha plus beta plus gamma is equal to minus b by a, minus b by a. And from 2 we can get alpha beta plus beta gamma plus gamma alpha is equal to c by k. Therefore alpha beta plus beta gamma plus gamma alpha is equal to c by k is nothing but a. This is second one. And from third we can get, third is alpha beta gamma is equal to, from this we can write minus d by k. So alpha beta gamma is equal to minus d by a. K is nothing but a. These are the relationship between zeros and coefficients of a polynomial. See here, alpha, beta and gamma plus sign is there. So it is nothing but sum of the zeros of a cubic polynomial. Sum of the zeros of a cubic polynomial is equal to minus b by a. That means b is here coefficient of x square divided by coefficient of x cube. Finally sum of the zeros of a cubic polynomial is equal to coefficient of x minus coefficient of x square by coefficient of x cube. And this one, how can we read this one? Alpha beta plus beta gamma plus gamma alpha is nothing but sum of, plus means sum of, it is alpha into beta means product, sum of product of zeros taken two at a time. Sum of product of zeros taken two at a time is equal to, C is nothing but coefficient of x, A is nothing but coefficient of x cube. So sum of product of zeros is equal to coefficient of x by coefficient of x cube. And this one is product of the zeros. Product of the zeros of the cubic polynomial is equal to minus d by a is nothing but d is here constant term, minus constant term by coefficient of x cube. So alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha equal to c by a. Alpha beta gamma is equal to minus d by a. This is the relationship between zeros and coefficients of a cubic polynomial. So, for suppose if they ask a problem, find the quadratic polynomial, find the cubic polynomial whose zeros are 2, 3 and 5 like that. If they ask me, I will tell you that. They ask find the quadratic polynomial whose zeros are 2, 3 and 5. So at that time, how can we calculate the quadratic polynomial? So these are the zeros of the cubic polynomial. Alpha is equal to 2, beta is equal to 3 and gamma is equal to 5. These are the zeros of the cubic polynomial. We know that this is the cubic polynomial. If three zeros are given, if three zeros alpha and beta and gamma are the three zeros of a cubic polynomial, then the cubic polynomial is k into x cube minus alpha plus beta n plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma, where k is not equal to 0 and k belongs to real numbers. See, first find alpha plus beta plus gamma is equal to 2 plus 3 plus 5 is nothing but 10. Alpha beta plus beta gamma plus gamma alpha is equal to 2 into 3 plus 3 into 5 plus 5 into 2 is equal to 2 3 6 plus 3 5 15 plus 10 is nothing but 31. Next, product of the zeros. Alpha beta gamma is equal to 2 into 3 into 5 is equal to 2 3 6 6 5 30. Therefore, the required cubic polynomial is nothing but k into x cube minus alpha plus beta plus gamma into x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. K not equal to 0, k belongs to R. So k into x cube minus this value is nothing but 10x plus alpha beta plus beta gamma alpha value is 31, x minus this one is 30. So for k equal to 1, the cubic polynomial is, the denominator is 1, so that for k equal to 1, the cubic polynomial is x cube minus 10x plus 31x minus 30. This is our required polynomial. So if the zeros they are given, then substitute take the values as alpha, beta and gamma. Next we have to find these terms and substitute these terms in this polynomial, then we get the required cubic polynomial. For suppose next here alpha, beta and gamma values they have given. If directly they have given, find the cubic polynomial whose sum of the zeros is 3, and sum of product of zeros taken two at a time is 5, and product of the zeros is minus 7, like that they have given us. At that time, how can we calculate? So directly they have given sum of the zeros, means alpha plus beta plus gamma, they have given 3. Sum of product of zeros taken two at a time, alpha beta plus beta gamma plus gamma alpha is equal to 5. And product of the zeros, they are given alpha, beta, gamma is equal to minus 7. Now substitute these values in this cubic polynomial, then we get the required cubic polynomial. This is about relationship between zeros and coefficients of a cubic polynomial. So here, see one of the important problem, that is, sometimes they will give the problem like this, and that means that they will give 3 zeros and verify the relationship between zeros and coefficients of a cubic polynomial. Let's see one problem, that is verify that 1 minus 1 minus 3 are the zeros of the polynomial or not. Zeros of the polynomial x cubed plus 3x square minus x minus 3, and check the relationship between zeros and the coefficients. So here what the problem they have given, verify that 1 minus 1 minus 3 are the zeros of the polynomial x cubed plus 3x square minus x minus 3, and check the relation between zeros and the coefficients. So if they have given particular this type of problems, how can we calculate? So first we have to assume this polynomial as p of x. Let p of x is equal to x cubed plus 3x square minus x minus 3. So how can we verify 1 is the zero of this polynomial? If we get the remainder is equal to 0, that means p of 1 equal to 0. If we get p of 1 equal to 0, then we say that 1 is the zero of this polynomial. If we get p of minus 1 is equal to 0, then we say that minus 1 is the zero of the polynomial, like that. So first we have to put x is equal to 1. This implies p of 1 is equal to, in place of x substitute 1 cube plus 3 into 1 square minus 1 minus 3. 1 cube is nothing but 1 plus 3 into 1 square nothing but 3. 1 plus 3 minus 1 minus 3 is nothing but minus 4. 1 plus 3 is 4. 4 minus 4, 0. Next, put x is equal to minus 1. P of minus 1 is equal to minus 1 whole cube plus 3 into minus 1 whole square minus, in place of x minus 1 minus 3. Okay. Minus 1 whole cube is nothing but minus 1. Minus 1 whole square is nothing but 1. 1 into 3, 3 plus 3. Minus 2 minus plus 1 minus 3. Minus 1 plus 1, 0. Plus 3 minus 3, 0. Totally 0. Put x is equal to minus 3. So p of minus 3 is equal to minus 3 whole cube plus 3 into minus 3 whole square. Minus of x value is minus 3. So minus 3 whole cube is nothing but minus 27. Minus 3 whole square means 9. 9 into 3, 27. Minus 2 minus plus 3 minus 3. Minus 27 plus 27 is nothing but 0. 3 plus minus 3, 0. So totally 0. So if you observe clearly here, p of 1 is equal to 0. P of minus 1 is equal to 0. P of minus 3 is equal to 0. So from this we can say that 1, minus 1 and minus 3 are the zeros of this polynomial p of x equal to x cube plus 3x square minus x minus 3. So we verified 1, minus 1 and minus 3 are the zeros. Clearly 1, minus 1 and minus 3 are the zeros of p of x. Now verify the relationship between zeros and coefficients of a polynomial. Relationship between zeros and coefficients of a polynomial. So first of all you have to compare this polynomial p of x equal to x cube plus 3x square minus x minus 3 with ax cube plus bx square plus cx plus d. You have to compare this polynomial with that. Then we get a is equal to ax cube plus bx square plus cx plus d. You have to compare with this. Then a is equal to x cube plus 3x square minus x minus 3. Then a is equal to 1, b is equal to 3, c is equal to, here x coefficient is c, here x coefficient is not 1, minus 1, b is equal to minus 3. So here what we get the zeros already, we verified the zeros are 1, minus 1 and minus 3. Let us assume that the zeros are alpha is equal to 1, beta is equal to minus 1, gamma is equal to minus 3. Now, what is the relationship between zeros and coefficients of a cubic polynomial? Alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a. And finally, alpha beta gamma is equal to minus d by a. That we have to verify now. Now, alpha plus beta plus gamma is equal to alpha is 1, beta is minus 1, minus 3. 1 minus 1, 0, 0 minus 3, minus 3. So this value is nothing but minus b by a, that we have to verify. So I want to write minus 3 as, so here write directly minus b by a. Write minus, what is b value? 3. By a value 1. Minus 3 is equal to minus 3 by 1. It is correct. Is equal to minus, right, as what is 3? B by a. So we verified alpha plus beta plus gamma is equal to minus b by a. And second one, alpha beta plus beta gamma plus gamma alpha is equal to, what is alpha? 1 into beta minus 1 plus minus 1 into gamma minus 3 plus minus 3 into alpha 1. 1 into minus 1, minus 1. Minus into minus plus 1 into 3. Minus 3 into 1, minus 3. So 3 minus 3, 0. Minus 1. So we have to verify alpha beta plus beta gamma plus gamma alpha equal to c by a or not. So I want to write c by a directly. What is c value? Minus 1. By what is c value? 1. So minus 1 can be written as minus 1 by 1 no? So that it is correct. So minus 1 by 1 is equal to minus 1. Minus 1 is nothing but c. By 1 is nothing but a. So finally alpha beta plus beta gamma plus gamma alpha is equal to c by a. Alpha, beta, gamma. Alpha is 1, beta is minus 1, gamma is minus 3. So finally 1 into minus 1, 1. 1 into minus 1, minus 1, minus 1 into minus 3, plus 3 is equal to, we have to verify alpha, beta, gamma is minus d by a or not. I am writing here minus d by a directly. So that is equal to, right, minus, d is what? Minus 3. D is minus 3. By a is what? 1. So we can write 3 as minus of minus 3 by 1. It is correct or not? True only. Minus 2 minus plus 3 by 1. 3 is equal to minus d by a. So finally, alpha, beta, gamma is equal to minus d by a. So we verified alpha plus beta plus gamma is equal to minus b by a. Alpha, beta plus beta, gamma plus gamma alpha equal to c by a. Alpha, beta, gamma is equal to minus d by a. So this is about this problem. So in this video we discussed totally the relationship between zeros and coefficients of a polynomial. In next video we can discuss about a division algorithm for polynomials. Thank you. Thank you.